The first topic is the so-called biovacancies. So a vacancy is where an atom is missing from one of the crystal lattice sites in solids or multiple sites, and it moves around. And it's been observed that baryonic matter and atoms are 99.9999% empty space, or electron shell clouds. And so there's a lot of empty space in biology and biological cells, and we know that it's been observed the space between neuron cells is up to 20% volume. And so, what if there are similarities between these so-called biovacancies and the vacancy behavior in fluids? If cellular interaction has some similar vacancy-like behavior, could have a potential role in disease. And almost like these electrical vacancies, do neural and skeletal voids share similar cell behavior to crystal lattice vacancies and defects in solids? Time shall tell. Second topic here is oxygen vacancies. We know that oxygen vacancies are some of the most common in metal oxides, and that they can lead to corrosion. And although some say that the oxygen atom is absent from crystal lattice, we know that vacancies typically drive inward into the solid material. And so the question is, how much percent of the vacancy behavior could be driven by oxygen or air moving through the lattice? The next topic is a solved mystery. There is this body armor. These material scientists, they came in and did this texture analysis to determine the grain boundary distribution and orientation of the crystal directions. They discovered from the texture analysis body armor could not have been built before the 1800s, and that this piece of metal was an imposter. The next topic here is space. It's about space and the effects of space and long-term space exposure and radiation in extreme environments put stress on materials and increase vacancy behavior. It's really the mystery to produce materials that can bear the extreme environments and temperatures of outer space. But then also as we ascend beyond Earth, the effects of the lack of electromagnetic fields on the crystal lattice dynamics. And so without these E field and B field flux lines to induce spin on the crystal orientation, how would the atomic orientation and the spin of phonons and atoms become misaligned and impact the overall material performance? And the last mystery here is on the topic of dark matter. Invented in 1928, the Dirac equation describes all spin of the 1/2 particles, such as electrons and antimatter, which was first predicted theoretically from this guy Dirac in 1928. And just as the square root of 4 can have two possible solutions, x equals 2 or -2, so he believed so do particles. Dirac proposed that for every particle there exists a corresponding antiparticle, and a particle with that matched the opposite charge. And so in his 1933 Nobel lecture, he proposed this correlation between dark matter and prediction of the electron dipole moments in their respective part interactions in the branching ratio and correlations between the properties of between dark matter and the decay of the Higgs boson. And so the question becomes, how can we detect and measure this dark matter and electrical dipole in experiments? So we'll have to think about these mysteries going forward, and thank you for tuning in, and catch you next time.